Hello, welcome to the video. Today I'd like to talk about Commodore cartridges. There seems to be a lot on the market now, and given this retro resurgence, the Commodore 64 has gained a lot of cartridges, and I thought I'd just take some time to explain how they work. So if we go back to the beginning, the Commodore 64 was based on a 6502 chip. That was made by MOS Technologies, and Commodore altered it slightly for the Commodore 64 with the addition of an 8-bit port, and then called it the 6510. So under the bonnet it's the same chip really, and that can only see 64K of memory. That's entire address space is 16 lines, and that gives you 2 to the 16th, which is 64K or 65,535. So in order for a game to work, it has to be mapped into that 64K of memory. So if we park the Commodore 64 for a second, and then we go to a predecessor, which was the VC10 or the Commodore Max machine. Now this only had 2K of memory. It had almost identical guts to the Commodore 64 in the same VIC, SID, blah 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 blah, but because of the low amount of memory, it took everything from its cartridge port. This is what led to the Ultimax mode in the Commodore 64. So to give you an idea, this is the Commodore 64 memory map, and I'll put that up on the screen. So as we can see, the kernel ROM is right at the top of memory, and the reason for that is when you first take a 652 or 6510 out of reset, the first thing it does, it goes to its reset vector, which is at the top of memory, and it gets 2 bytes, and those 2 bytes are the low and high byte of an address to start executing code. So normally when you power up the 64, it goes through its memory checks and whatever else. It does that because it drops out of reset and goes to the kernel, and that's where the kernel lives, and it lives right at the top of memory, and it's an 8K block, and it's from E000 up to the top mem. So when you use an Ultimax cartridge in a Commodore 64, it wipes out the kernel, and it does that by manipulating some data lines. And the interesting thing here is the Commodore 64 has got attached to that extra 8-bit port that I spoke about something called the PLA chip, and the PLA, its main use was to switch in and out chips as it needs them. Now it gets a little bit complicated in that the Commodore 64 has 2 cycles, 2 halves of a cycle to be more exact, and during the first half the CPU has control of everything attached to the address bus, and during the second half the VIC chip has everything attached to it. So the VIC chip can go and talk to stuff as well, and that's so it can use memory for sprites and stuff like that. So anyway, back to cartridges. So your main types of cartridges were Ultimax or regular 8 or 16K cartridges. Now I have built this, if it focuses. This is a VersaCart 64. This is only a 1.4. You can get these off PCBWay or your PCB supplier of choice. But yeah, these are freely downloadable as Gerber files, so you can get them on there. If you go to PCBWay, you can just download, click the link, and then they'll send them to you. And you can get 10 boards for $5. I mean, yeah, it's a no-brainer. But anyway, these boards, these can use all different sorts of things in regards to cartridges. You've got dip switches on here to set the upper address lines. You can tell it what the signals are, and you can basically say you can have a single game or multiple games on it. So you could have a 64K cartridge and put 8 games on it, and they could be 8 games, or you could have 4 16K games, or you could have 8 Ultimax games. or you can have single ones if you want. It's really open, so you can do anything you like to it. So with different addressing modes, what you have is 8K, 16K and Ultimax. So Ultimax games, the most common one that I think people that had a Commodore 64, they'll know that Jupiter Lander was an Ultimax cartridge, and that wipes out the top memory. So if you had a knackered kernel, you could whop in a Jupiter Lander cartridge, wham, and it'd work. It'd power up, you could play it. It's because it takes the same memory space. And it does that because when you toggle certain lines, the game and XROM, the PLA allows it to map different parts of memory and present that to the C64 CPU as just regular address space. So if we look at the documentation for the VersaCart, that explains it a bit more. So as you can see here, you've got ROM-L, ROM-H, and then you've got game and XROM lines. Now they do slightly different things. The game and XROM is what the outside world sets to tell the PLA what it wants to do. So if you want to be an 8K Ultimax game, that says here that XROM would be high and game would be low, and it would then use the ROM-H and the ROM-L as your chip selector to actually activate them. So you think of your game and your XROM are lines going into the 64 to say, yep, this is how I want it configured, and then the PLA comes back with, I'll turn on that chip with ROM-L or ROM-H. So they're the ones coming out of the 64. And what that means is that you've got a massive amount of different cartridges you can use. Massive. But if we take the example of the Ultimax still, we can set XROM to high, game to low. It will come out on ROM-H, and it will map into E000 all the way up to top mem, which is FFFF. Now, if you want to use a regular cartridge as 8K, you'd present those lines slightly differently. So you would bring your XROM to low and your game to high, and that would map it into a different area of memory, specifically 8000, and that would go to 8000 to 9FFF, which, if you know your hexadecimal, is an 8K block in the middle of memory. And if you want a 16K, the first block is the same. So your XROM and game would both be low, and your first block at 08000 would be your first 8K block. But your second block, to give you the 16K, would end at BFFF. So you instead of having one 8K block, it'd expand it to 16, but it'd start at the same place. And I believe that when you use a regular cartridge, just 8 or 16K, I think there's a 5-character string called CBM80 that it looks for before it activates the code in the cartridge. So when you want a standard game, you've got 3 choices. You've got 8K, 16K or Ultimax. And like I said, you can build these cartridges yourself super easy. It really is. When you want to do some other stuff, things get a little more complicated, but it depends what you want. If you're a hobbyist and you want to make a cartridge, and they're not complicated by any stretch, I really do suggest you try it, then a VersaCart is a very good way of going. But if you just want to play some games, then your options change. This is a Kung Fu Flash cartridge. This is one I built and printed a case for. This can take an SD card and it can play pretty much any cartridge you can chuck at it. You put it on there as a ROM file and bam, you've got a nice little menu, it can play them all. Happy days. There's a small ST microcontroller in here that talks to the 64, and all it does is it sets up a bit of flash memory as RAM and then presents that to the 64. So yeah, no problem. This can also do more complicated sort of things. You've got bank switching carts, which I'll get to later, easy flash, all sorts. So this is the Kung Fu flash cart, and if you want a cheap way of getting into things, these can be picked up for about 25 quid already made, or if you want to make your own, you can do this for about 15 quid. They're not expensive. This is an easy flash. This is the very first easy flash. This has got 1 megabyte of address space in it, and it does that by bank switching. And bank switching is a way of taking an 8 or 16k chunk of RAM that I just spoke about and then mapping that to different banks inside the cartridge. And that way you can present a far greater size of memory. So some games, namely ocean games, are like 128k up to 512k just for one game, and that's because it bank switches it. It uses a different port to do that, D000 I think off the top of my head. But the principle is, as soon as the code writes to that address, the cartridge itself banks in a different block so that the 64 can see that block in that address space. After the Easy Flash came out, you had the Easy Flash 3. Oh yeah. Now this beast, this is something else. This can do more than an Easy Flash. This can hold 8 Easy Flash images, that's 8 megabytes on it. It can also act like a kernel, write a new kernel into memory, and it can do some other funky stuff as well. You can even use it as a freezer cartridge. And then you've got lots of other projects out there that use cartridges. This is a Sidekick. Yeah, it's got a Raspberry Pi in it, and it can do everything an Easy Flash can. It can do some more stuff as well. I mean, you can put converters on this and use it with VIC-20 or C16 if you want to. It can have up to 8 virtual SID chips. It's a bit of a beast, but it's going to cost you more to build than a Kung Fu Flash. And of course, if you want the absolute pinnacle of a cartridge, it is the ultimate cartridge, and it's not lying. It can emulate pretty much perfectly 4 disk drives, a tape drive, and it will play any cartridge format that you can think of. If you want to go with something that's simple to build and a lot of memory space, and you've got a bit of technical ability, then you can build something like a Magic Desk cartridge. Now, this particular one is a Magic Desk 2, so it's a 2 megabyte version. As you can see, it will take a big chip when I programmed it, and 2 megabytes holds a lot of C64 games, a lot. So making your own cartridges is a fun way to get into a bit of soldering, or if you're not au fait with that sort of thing, it's a nice little project that you can do for your Commodore, and it can get you into making your own custom cartridges. You can also buy them off eBay. I mean, here's a Zaxxon cartridge. Now this is a bit of a white elephant in that it's 12k and does something pretty nasty to the bus in order to get it to work. So the reason why I've got one of these is, if you want to give your PLA a workout, this is the way to do it. Yeah. But making your own cartridges means that you can make a compilation of games that is unique to you, the ones that you like or you remembered playing on, and for that, Magic Desk. Now this is a case I printed for some boards I made, and this one was August 20. So yeah, that's 1 meg of games on here, instant loading, there's a menu system, works really well. 8-Bit Retro Refix did a good video on Magic Desk, and this one here that I've still got a program is the Magic Desk 2, so this is a 2 meg version, and it's a little bit of a cheat because you've got like a a selector button up here that flips between 1 meg and the other 1 meg. So yeah, I'm not really going to say it's a 2 meg. It does hold 2 meg, but yeah, you've got to select which half of the chip you want to read. So yeah, but either way, 2 megabytes holds that's a lot of games for the 64, and it's not complicated to build, and it's a nice little project. But if you just want to play them, like I said, the Kung Fu Flash is a superb alternative. This is the Ultimate cartridge that I mentioned earlier. These are like the top of the top. You won't get any better. They're just simply the best. But you're going to pay for that. But if you do like to build things and you want to have a go at something, the Kung Fu Flash is not that difficult. The Sidekick is not that difficult to build, and both are great alternatives. But if you're just getting started, just go onto PCBWay or whatever, get a Versa 64 cartridge, and then just blast some games into it. All you need is an EEPROM programmer and a handful of components. I mean, for this, there's a couple of resistors on there, a couple of diodes, and a switch. The switch is optional, so you don't actually need it. And then a dip switch. You can get all the components to build 10 of these for probably a £5. You can get 10 boards for a £5, so it'll cost you a tenner and you can build 10 boards. You're going to have to get some EEPROMs though. So yeah, I suppose EEPROMs are about 60 or 70 pence each and not expensive. You can go to AliExpress or whatever and just get them sent over on the slow boat, and yeah, then you just got to program it up. But if you're just looking to get into some light gaming, then perhaps building a cartridge might not be the way to go, and the Kung Fu Flash or something would be. But hopefully this is just giving you a little primer into how cartridges work. It's quite complicated to begin with until you understand it, and then it's extremely simple. Back in the day when we all had Commodores, we didn't know a lot of this because the internet didn't exist. You didn't have YouTube videos, and all you had is, you know, books, or you knew someone that knew a bit. So now it's completely possible to understand how these machines work in their entirety, whereas you couldn't back then. So yeah, I'm going to wrap this video up now. It was only intended to be a quick one anyway. As always, I'm going to say check out my compadres in the description, and check out the the Discord server. Come along and say hi. Yeah, there's a group of us on there that it's a nice light-hearted place where you can just come along and just talk about old computers. So take it easy until the next one.